Hello everyone. Today in this video I'll be explaining you speed, distance and time, basic concepts and also to solve any problem on straight line motion. So in any exam, what type of problems we can face in speed, time and distance? So there are basically uh, five, six types of problem which we can face in speed, time and distance. Right? They could be categorized into first type of problem is motion in straight line. So which is very famous type of problems and which are observed maximum. Then we have relative motion problems. Then there are some train problems. So based on speed of train and there are several type of problems in trains also. Then problems on boats. Then we have circular motion problems. Which are basically either races problem or problems of race or problem of clocks. So these are basic type of problems we face. So important basic formula which we apply here is speed is equal to distance upon time. So we just have to remember this formula. This is the basic formula and applied everywhere, right? And here if we know two variables, we can easily find the third variables. Now speed can be written as the unit of speed could be kilometer per hour. It could be meter per second or kilometer per minute or nautical miles per hour. So basically we have distance here and time here, so it could be written in any form. So majorly we find two basic type of units, which is kilometer per hour and meter per second, right? So we should understand how we can convert from kilometer per hour to meter per second and meter per second to kilometer per hour. So when we have to convert from kilometer per hour to meter per second, what we do, we simply multiply by 5 by 18. So how the figure of 5 by 18 comes? Simply kilometer per hour could be written as 1000 meters upon 60 into 60 seconds, right? So this will give us 5 by 18 meter per second. So to convert kilometer per hour to meter per second, we just have to multiply by 5 by 18, and vice versa from meter per second to kilometer per hour, we just have to multiply by inverse of this, that is 18 by 5, right? So first important concept here is proportionality concept. Proportionality concept. So simply we have a formula, speed is equal to distance upon time. So that means if any one thing is constant, other two things would be proportional. So in first case, if time is constant, we have speed proportional to distance, directly proportional to distance, right? In second case, if speed is constant, so what will happen? Distance will be proportional to time, directly proportional to time, right? In third case, if distance is constant, so what will happen? Speed will be inversely proportional to time, right? So let's start with let me explain you when time is constant. Let's start with this. So let's say person is traveling from A to towards B one person is traveling in this direction and the other person is traveling in this direction, and they are meeting at C, right? If they are meeting, that means time is constant, so at the same time they would be meeting here. So let's say speed of A is 10 kmph and speed of B is 20 kmph. Okay, this distance is d1, this distance is d2. So let's say d1 is 5, so we'll simply use s of A upon s of B. Speed is directly proportional to distance, so distance 1 upon distance 2, or speed of A was 10, speed of B was 20, so d1 was 5, so d2 can be found out. So d2 would be 10 kilometers here, right? So using proportionality constant, we don't have to solve the entire thing and then find. So it's simply, we know they are meeting at the same time and we have proceeded from there. Now let's take second example where speed is constant. Okay, for speed constant, let's say there is one person who is traveling from point A. Let me change the color. Okay, let's say there is one person who is traveling from A to B, and then from B to C at constant speed. Constant speed. Okay, and he's traveling from A to B in 1 hour and from B to C in 2 hours. Let's say this distance d1 is 8 kilometers. Then we have to find this distance d2. So how we can do this? Using speed as constant, time is directly proportional to distance. So d1 upon d2 would be d1 upon d2 simply, or d1 was 1, d2 was 2, d1 was 8, d2 we have to find, so d2 would be 16 kilometers. Okay, so let's take third type where we have distance as constant. Okay, so let's say a person is traveling from A to C. Yeah, there A, B and C. He's traveling half the distance in time t1 with speed s1 and rest half of the distance in time t2 and speed s2, right? So here simply speed is inversely proportional to time, so s1 upon s2 will be t2 upon t1 simply, right? So let's come to the next concept, that is relativity concept. Okay, so let's say there are two persons A and B traveling with the speed s1 and s2 towards each other, right? So if they are traveling in opposite direction, what is, their speeds are adding up, right? So their distance would be between A and B distance and their speed would be adding up. So opposite direction speed would be, speed relative would be s1 plus s2. Similarly, if they are moving in same direction, let's say they are racing, A and B are racing from here. A is traveling with s1, B is traveling with s2, going in the same direction, right? So relative speed would be s1 minus s2 or s2 minus s1, whichever is greater. So I'll write mod here, right? So that's the concept of relativity, which is very important concept and appears everywhere, be it train problem, boat problem, circular motion problems, straight line motion problem. So it will be everywhere. So let's come to first type of straight line problems. So in which let's say there are 2 points, two cities A and B, right? Two cities A and B, and there are two buses which starts from A, one with the speed S1, another one with the speed S2. Okay, and they keep on going to and fro from A to B, B to A, A to B, B to A. So we have to find out when do they meet. First they will be meeting for the first time at somewhere here at point C, right? Then again they will meet somewhere, and again they will meet somewhere. So total distance that they would be covering. So in first meeting, what distance would they be covering? S1 would have this. Let's see, person 1 would have traveled from A to C, right? So that will be d minus x, right? Suppose this is total distance is d and this is x, so this will be d minus x, right? So A would have traveled d minus x, first person would have traveled d minus x, second person would have traveled total of d plus extra of x. He would have gone to B then back. So total distance traveled would be 2d. Similarly, so first meeting total distance traveled would be 2d. Similarly, in second meeting total distance would be 2 into 2d, right? 2 times. Similarly, nth time they would have traveled n times of 2d. And what was their speed? The relative speed, since they were traveling in same direction, speed would have been S2 minus S1, since we are considering S2 as greater than S1. So time for first meeting would be T1. It will be distance upon time. So distance was 2d, time was S2 minus S1. Similarly for second time it would be 2 into 2d upon speed is again same S2 minus S1. For nth time this time would be n into 2d upon S2 minus S1. Okay. In second type of problems of speed, the straight line motion, so they would be starting from different cities. So let's say they starts from one bus starts from A with speed S1 and second bus starts from B with speed S2. So they would be meeting first time in some city C. So S1 would have traveled X distance and S2 would have traveled d minus x travel distance. So total distance they would have traveled would be d, right? And their relative speed would be s1 plus s2, right? So in first meeting is happening at total distance traveled is d. Similarly for second time when they have to meet, now second time they would be traveling, this A would have met here, then this A would have gone back to B, then again came somewhere. Similarly for second meeting B would have gone here, then again came back, so they would have met here. So 2d distance extra they would have traveled. So in second meeting total distance is d plus 2 into 2d. Similarly for nth meeting total distance they would have traveled would be d plus n minus 1 into 2d, right? So time would be using distance upon speed, so t1 would be d upon s1 plus s2, d2 would be d into 2d, sorry, d plus 2 into 2d upon s1 plus s2. Similarly, tn for nth time when they meet, time elapsed would have been t plus n minus 1 into 2d upon s1 plus s2. Right? Okay, now let's solve one question and see what type of question we can face in this straight line motion. So let's say there are two persons P and Q, okay, who are starting from A, and the person Q starting from point B, and they're meeting somewhere at point C, which is at a distance of 0.4d from here, right? This is 0.4d. If this is 0.4d, this would be 0.60. Now we have to find let's say fifth meeting point. Where would be fifth meeting point, right? So how do we solve this question? So we know when they are meeting for the first time at C, so here time is constant, right? Time is constant, so we'll use proportionality concept. Speed is directly proportional to distance, right? So S of P upon S of Q would be equal to 0.4d upon 0.60 equals to 2 by 3, right? Now we also know for fifth meeting point, what would be distance? Distance would be d plus n minus 1, 5 minus 1 into 2d, that is equal to 9d, right? So from this speed ratio, d of distance traveled by p would be in the proportion of speed, right? So 2 upon 5, 2 upon 2 plus 3 into 9d is equal to 18 divided by 5 is 3.6 d, right? So it is 3.60, so that means this p would have traveled 1, 2, 3 and then back 0.6. So fifth meeting point would be again 0.4d distance from A. So answer is 0.4d from A. Okay, so thank you for watching. In next video I'll be taking your board problems, then circular motion problem, clock problems. So stay tuned, keep watching. Thank you.